Hello, Mr. Gazda here. 81, Applied Physics, friction questions. There's some key stuff at the top. Static friction is the friction between two materials when an object is not moving. Static means not moving. Kinetic is the friction force between two materials when an object is in motion, it is moving. Key thing, static friction will always be greater than kinetic friction, and basically it will take more force to get a object moving if you're sliding across the floor, more force to start it moving than it is to keep it moving. That is key. So the coefficient of static friction will always be higher than the coefficient of kinetic friction. More force will be required to start an object in motion than to keep it in motion. This is key. Know these things, okay? And I added here force of friction formula is on the reference table, and it is on the back, and it's this. Okay, force of friction, that is the frictional coefficient, which coefficient of friction, which is listed here, and then times the normal force. So here we go. On the box above, draw a vector that represents the weight of the box. Label it W. Now we're kind of just estimating how much it weighs. Okay, we don't know. The length of the vector will normally shows what the magnitude is, but here we're just kind of estimating. I just want people to show the direction that this is going to represent the weight of the box. And then 2, on the box above, draw a vector that represents the normal force acting on the box. Normal force is basically the surface here, if it's the table or the floor, pushing back on the box, and it's going to be opposite and equal the weight. So I'm going to try my best, and maybe I will even mark it here to sort of get the length right there, and then I'm going to make it go right to there to show equal and opposite the weight, and that is the normal force is what that's called. And then 3 says a force is applied to the box as shown by the dark vector above. That's what this is, so force is going this way. And in italics it says the force is not enough to cause the box to move, however. That is important. Okay, the box is not moving, so you applied force to it, but it does not get that box moving. So draw in a vector representing the force of friction. Note the scale of your drawing matters. Now what I mean by that, if it's trying to pull it this way, the force of friction is going to resist it and be in this direction. Now the length, what's key is that if it's not moving, the friction force in the opposite direction must be more than this. So that's what I meant by the scale. So you could do something like this. It doesn't have to be exact here, we're trying to get the idea. So it must be longer than there. So for instance, you could draw it. You could draw that frictional force, and you could draw the frictional force to be definitely longer than there. So for anything longer than there, that's what I mean. Okay, and it should be force of friction. I don't think it says label it, but you should. Force of friction in the opposite direction. So you're pushing it a little bit, but not enough to overcome this. Therefore, that object will not be moving. That's a key point here. 4, for the box above, the coefficient of friction is 0.44. Calculate the force of static friction between the box and the floor. Show your math below. So I go to my reference table here, start with the formula, and force of friction equals, that's the coefficient of friction, in this case it's static friction, times the normal force. Sorry, the n should be a little smaller. That's like a subscript. Okay, so what am I calculating? I'm calculating this, so I could just plug these numbers in. Coefficient of friction is 0.44, and I times that by the weight. Weight is shown there. I'm sorry, normal force, which is the normal force, which is the just opposite the weight. Okay, so I could just use that number. Okay, and when you multiply those together with my calculator, right, 0.44 times 237 equals, and the pounds are in there, so the force of friction will be just that 104.28 pounds. 104.28 pounds of static friction in this case. Therefore, if you want to move this box and slide it, you have to push at least 104 pounds of force on it just to get it to sort of overcome that static friction. Okay. If this was lower, there's less friction between them, you do apply less force to it. 5. For the box above, the coefficient of static friction is at 0.19, so it's less. calculate the force of static friction between the box and the floor. Show your math below. Force of friction equals times the normal force. Therefore, what I have here is force of friction equals the 0.19 times the normal force, which again is just the same value as the weight. It's just in its opposite direction. So in this case, we're measuring them with kilograms. Okay, and we just do that math. 0.19 times 53.3. So now your force of friction is 10. I'll round it to like this, and that's kilograms. Units are vital here, whether using pounds or kilograms or grams or whatever it may be. Okay? So those are pretty straightforward ones. 6 and 7 are a little bit different. So, weight of the box is 77 pounds. Here's the box, here's the surface, or what does it say, counter. In the diagram above, the block is made of wood and it is resting on a stainless steel counter. 16 pounds of horizontal force is what it takes to get the block moving. So I could sort of say force applied. I could say 16 pounds. If you want to do this, it's good to just get it in your head. Label these diagrams and make use of it. Calculate the coefficient of static friction, please. Round to a decimal place you think is reasonable. Show your math. So check this out. So this is what we're looking for. This is our question mark. What do we know? We know the force, just to get it moving, we know that that 16 pounds is the force of static friction in that case, is 16 pounds. Okay, so because you have to just overcome that to make it move, and so that's what that represents, and that's key to this. And the weight of the box, 77 pounds, therefore the normal force will also be 77 pounds. So let's plug this into our formula. Force of friction equals, what are we doing? It's the static friction here, times the normal force. So we're looking for that, we have that, we have that. So we're going to have 16 pounds equals coefficient of static friction and your normal force, which is 77 pounds. Okay, we want to get this by itself, so we'll divide 77 pounds here. That cancels out, and then we do 77 pounds here. And if you properly glyph the units, as we call it, the pounds over pounds will be 1 and cancel out, so the units kind of drop out. And we do 16 divided by 77 is 0. Now, don't write all those numbers, okay? So maybe 0.21, and I go off that really because that's kind of reasonable. And also, if you look at the front here of the reference table, this is what they usually, their sort of general form. We round them to 2 decimal places. So, but definitely write in all these numbers. Obviously, whether that's a 2 or a 4 or a 9 doesn't affect us very much in our normal world. It's such a small. So don't write all those numbers. That was my point there. And then in 7, excuse me, in the diagram above, the block is made of textured stone and is resting on a concrete floor with a rough texture. 295 pounds of horizontal force is what it takes to get the block to start moving. So we could do, you know, if you want to label, definitely label the diagram to help you for sure. So that's normal normal force 80 pounds, and then I apply, if I'm moving it this way, my force is applied 295 pounds of force. We're calculating the coefficient of static friction. Same basic idea. Force of friction in this case. So just to get it moving, again, force of friction, static friction, is 295 pounds. The normal force here is 480 pounds. And the coefficient of friction is what we are looking for. So we can plug these numbers in to our formula. Force of friction, static, F sub n. So that's 295 pounds equals, and then 480 pounds. Same thing as we did before. We want to get this by itself, so we divide this whole thing by 480 pounds. Cancel out. Do it to this side. 480 pounds. Pounds cancel out. So you do that with the units, it really helps. And I do 295 divided by 480 will give me probably a reason 0.61. Again, don't write all those numbers. Alright. And then 8, I do like the question of 8. Estimate an approximate value for the UK kinetic value of friction for the two surfaces above. You calculated the static friction as 0.61. Page 1 of the reference table may be able to help your thought process. So go here, okay, and my idea is that you have to know, is the kinetic coefficient, is it going to be the same, more, or less? Okay, so if you look up here, it will be less because it's easier to keep it going once it's going. So I'll tell you that much, it will be less. Now how much less, you have to estimate. You're not going to know it, but just look here to help you estimate. That's my hint here. I'll let you do the rest of that and you're going to try to figure that out, okay? So that is some of the basics of calculating friction. Alright, I hope that helps. I'm Mr. Gazda, and we here at Gazdonian Productions will put our seal on this, like that. I hope this helped, and thanks for watching.